Hey everybody, Dr. T here from Mad Science of Washington. I'm here in the Mad Science Lab up in Silver Spring to show you guys a few cool activities. But before we get to that, you may have seen Mad Science before. We come out to the Washington Wizards Kids Day every January, as well as other events put on by the Wizards and Monumental Sports. So we're excited to be here again with you today virtually, and we can't wait to see you guys at some of those in-person events, hopefully in the pretty near future. But in the meantime, let's talk a little bit more about science, and specifically the science of basketball. So, we are going to talk today a little bit about how basketballs actually bounce, and then we're going to talk a little bit about energy. And as it turns out, both of those things are pretty related. So to do that, we first need to talk a little bit about motion. Now, some of you may have heard of a scientist named Sir Isaac Newton. Now, Sir Isaac Newton came up with 3 laws of motion. Okay, and those are, when we say laws in science, we're not talking about laws like you might have in the real world, right? Where you might, you can't break the law. Well, in science, it's a little different. In science, you literally cannot break the law. If something is a law in science, it is impossible to not follow it. So in the case of the laws of motion, these are laws that tell us how things move, and there's no way to go around that. Now, the third law of motion basically says that for every action, there is an equal and opposite reaction. Now, what that means is, whenever object A hits object B will hit object A back with the same amount of force. So, to put another example here, how many of you guys have ever fallen down from something kind of high, like maybe a tree or something? Yeah, I know, probably hurt a little bit, didn't it? I bet. Well, when that happened, the part that hurt was not actually when you fell out of the tree and hit the ground. That did happen, but what happened next was that the ground came back, and the ground hit you back with the same amount of force. Sounds kind of crazy, but that's exactly what happens. Alright, so that is basically Newton's third law of motion, and not hard to see how that applies to basketballs. When a basketball drops, right, it'll hit this table in my case, or the basketball court when you're playing basketball, and just like when you were to fall out of the tree and hit the ground, where it kind of hurt your arm a little bit, or wherever you landed, right, well, obviously doesn't hurt the basketball, but it does hit it with the same amount of force that the basketball came down with, and that sends the basketball into the air again. Alright, so what happens, guys, is you can't quite see it because a lot of it happens extremely fast, but if you were to watch a basketball in slow motion, you would see that when it hits the ground, it actually gets flattened a little bit, like almost squashed, like it goes splat. But it instantly pops back out and hits the ground and goes flying into the air. A good example of what it would look like would be if you were to take this look at this little clay ball right here. So if I were to toss this clay ball against a hard surface, it wouldn't bounce, but you would see that it would start to flatten on that end right there. Now, like I said, that's what happens to the basketball, except with the basketball, it pops back out and then it bounces. So, you may notice that eventually, if you were to bounce a basketball, it would not keep on bouncing forever. Eventually, it would bounce a little lower, then a little lower, and then a little lower, and then it would finally stop. Well, here's why. When a basketball hits the ground and bounces up, it also releases some of its energy. So let's talk about energy. So when I hold this basketball up, it has energy right now. That's called potential energy, which means energy that hasn't been used yet. So in this case, it's got energy waiting to be used, but it's not going to be used until I let it go, at which point gravity will pull it down, and that energy, that potential energy, will convert into what we call kinetic energy, which is the energy of motion, of things moving. So when I let go, this basketball, the potential energy converts to kinetic energy, then it hits the ground, at which point some of that remains kinetic energy and causes it to bounce up again, but some of it converts to heat energy. The impact of that basketball hitting the ground is kind of hot, and you may notice that your basketball starts to feel kind of hot once you've been using it for a while. So, since some of that energy is lost into the air as heat energy, there's not quite as much energy bouncing the basketball up as there was when you were initially holding it up or when you pushed it down in the case of dribbling. And so, every time that happens, the basketball loses a little bit of heat energy to the air, and so it bounces lower and lower and lower until it eventually stops. And so, Basketballs, just like you, when you eat food to get energy, and you use up all that energy by running around, you start to run out of it. Well, basketballs work the same way. They run out of energy too. Alright guys, well thank you for joining me today here in the Mad Science Lab. I cannot wait to see you guys again sometime in person at the next Washington Wizards event. But until then, it's great having you join us here virtually in the Mad Science Lab. I hope to see you soon.